Hi, my name is Samara Doshi, and this is my presentation for Physics 2212, Lab 1 on charge tapes. In this experiment, I explored electrostatic charge using nothing more than clear tape and investigated how everyday materials could hold and transfer electric charge. The main goal was to estimate how much excess charge would end up on a single piece of tape throughout this process. So, electric charge is a fundamental property of matter which causes objects to exert forces in the presence of electric or magnetic fields. And there are two types of charge, positive and negative, and they exist in particles like electrons and protons, respectively. And in this lab, we used these basic principles to create electric effects that were observable using pieces of scotch tape, which let me directly see how charged objects interact. So, the main goal of this lab was to calculate the amount of excess charge on a single strip of tape. And to do this, I first created two tapes that became charged through a separation process. And then I observed how those charged tapes interacted with each other and with neutral materials. And then I used their floating distance and some other assumptions that I'll discuss in a bit to estimate the magnitude of their charge. And then I modeled the setup using GlowScript in Python to simulate electric forces that were acting on the tape. So, some of the key principles that were used in this lab, there were three main physical concepts. One was Newton's second law, which stated that force equals mass times acceleration, but in this case, we used it to set the net force to zero. And then there was also the gravitational force, which calculated the downward force on the tape as F is equal to mg. And then there was Coulomb's law, which basically helped me estimate the repulsive force between two identically charged tapes. And the formula is F is equal to K Q1 Q2 by R square. By equating the electric repulsion with the gravitational force at the point where one tape floated, I could solve for the unknown charge of Q. Now, some of the assumptions that I made, there were several assumptions. One was that air resistance was ignored. Then each tape was treated as if the charge on it was concentrated in the center, like a point charge. And then both tapes were assumed to carry equal charges. And then I also assumed the equilibrium occurs when electric repulsion exactly cancels out the weight of the upper tape. And basically, these assumptions allowed me to apply basic physics equations to more complex real world situations. Now, the models. Here I used my measurements to estimate the charge on the tape, and the mass of each tape was assumed to be 4e minus 4 kgs. The tape length was 0.2 meters. The width of the tape was 0.05 meters. The number of atoms on the tape were 1e18, and then the charge on the tape was 3.92 e minus 3. And we using F is equal to mg, we calculate the gravitational force, and then we used Coulomb's law to solve for the charge Q. To also understand the scale, I divided by the elementary charge and found that this meant that there was an electron deficiency of 8.25 E10, which was a really large number for something so small. And now for the GlowScript code, I use GlowScript to visualize the electric field interactions between the tapes. And in this code, I input my calculated values for mass, distance, and charge. And then the simulation demonstrated how one tape hovers above the other when the electric repulsion balances the downward gravitational force. And it helped understand the interaction in a dynamic manner. Now, for some of the potential sources of error, one was that measuring the distances between the floating tapes was not perfectly precise, and some charge could have been lost through handling, and the tapes might not have had identical charges, which could have all affected the accuracy of the charge calculation. Now, there were two questions that were answered at the end. If the electrons were positive and the protons were negative, it wouldn't affect the results because physics laws like attraction and repulsion are based on relative charge. And then why are the point charge and line charge models different? The point charge model assumes that all the charge is in the center of the tape, but the line charge model spreads it across the length. And therefore, the line model is more realistic because the charge actually distributes over the tape's surface, so it's likely to give a more accurate result. Thank you.